Now let's talk about inverse functions. So first of all, an inverse operation undoes what the original function does, right? So it undoes whatever our original function does. So here, this is multiplying a number by 8. So to undo that, we would divide by 8. That makes these inverse operations. Let's look at a specific example. 8 times 12 is 96. So if I take 96 and divide by 8, I get back to 12. In other words, what this is saying is if I compose a function on its inverse, I get back to what I started with. And the other way around, if I compose an inverse on its function, I get back to what I started with. So for two inverse functions, these are always true. The composition of f and its inverse function, or the other way around, its inverse function in f, always give me back originally what I started with. Now, what kind of functions have inverses that are also functions? Well, those are one-to-one functions. A function is one-to-one if every x corresponds to a y, that makes it a function. And every y corresponds to only one x, that makes it one-to-one. All right, so whenever two x's are different, the y's are different. Let's decide whether each function is one-to-one. First of all, square root of 25 minus x squared. Well, if I look at 3 and negative 3, they give me the exact same y value, so it is not one-to-one. I just need one example of it happening with a y value to prove that the function is not one-to-one. Negative 4x plus 2, however, is one-to-one. Now, the way that we demonstrate that, we can't just randomly choose values. We have to demonstrate it's true for all x's. So I say, when are the y values equal? Only if this y value, this formula for the y value is equal to this formula for the y value. So go ahead and simplify, subtract 12 from each side, divide by negative 4. That means that the x values must be the same value. So it is one-to-one. A one-to-one function passes the horizontal line test if every horizontal line hits the graph in only one place. It's a one-to-one function. Here it does not. This horizontal line intersects 3 times, and these are all the same y values on a horizontal line. So that means there are multiple x's that have the same y value. So this one is not a function. I'm sorry, is not a one-to-one function. It is a function, right? But it's not one-to-one. Over here, every single y value corresponds to only one x. We see that because no horizontal line intersects in more than one place. So this one is one-to-one. So two functions are inverses of one another if when I compose them, I get back what I started with in both directions. All right, I want to determine, are these two inverse functions? So the first thing that I do is I look at f of g of x. So that's putting g of x, which is x over 2 plus 5 halves, in as the variable in this expression. So 2 times this x is now this guy, x over 2 plus 5 over 2 minus 5. I'm just finishing off our formula here. Go ahead and distribute the 2, and we get 2 times this divided by 2. We'll leave just x. And the same thing here, we'll leave just plus 5 minus 5. And we get just back x. So that works in that direction. Now let's check the other direction. So we go g of f of x. So everywhere in g that I have an x, I'm going to replace it with 2x minus 5. So we're going right here and replacing this x with 2x minus 5 over 2 plus 5 over 2, finishing off this function. So go ahead and simplify here. We get 2x over 2 minus 5 over 2 plus 5 over 2. These subtract off. And then 2x over 2 is just x. That works. So f and g are inverses. And our notation for the inverse is a superscript of a negative 1. Now don't confuse this with the exponent. If I write 5 to the negative 1, that means 1 over 5. But f applied to a function, it does not mean a reciprocal. It means an inverse. All right, so that's our notation, f inverse. That's the way we read it. And what it does is any x that I pick up and run through f, if I pick up the y that's associated with it and run it through the inverse, I get back to what I started with. Remember, it undoes what the original function does. So the original function takes this x and turns it into a y. So the inverse will undo that. It'll take that y and turn it into an x. Determine whether each function is 1 to 1. 1 to 1 means every x has only one y. So let's look here. 3, 6, 9, 6. Oh, look at this. Same y value, 2 different x's. Not 1 to 1. Now let's look here. Negative 1, 5, 3, 0. Those are all different y's. So this one is 1, 2, 1. All right, so I need to find G inverse. So G inverse, well, let's see. It's going to take this y value and turn it back into an x. So that means this is the input and that's the output. So negative 1 is the input and negative 3 is the output. 5 is the input, 0 is the output. Notice that what I'm doing here ends up being just reversing all the x and y coordinates. That's what happens between an inverse and its function. All of the x's become y's, all of the y's become x. The domain of the inverse is the range of the original function. The domain of the original function is the range of the inverse. They flip places. So it flips the x's and y's. So how do we find the equation of an inverse function? Flip your x's and y's. That's what we just said. Solve for y and rewrite it as f inverse of x. So decide whether f is a one-to-one function. This is a line, right? 3x minus 8 would be a line with a y-intercept of negative 8 and a slope of 3. That's going to pass the horizontal line test. So yes. So now find its inverse. So we write this as y equals 3x minus 8. Flip your x's and y's. X equals 3y minus 8. Now solve for y. So I'm going to add 8 to both sides and then divide by 3. So y would be x plus 8 over 3. So our f inverse of x is x plus 8 over 3. Let's do the same thing here. Now, let's look at this. This is a parabola shifted up 6 units. A parabola shifted up 6 units would look like that. That's not one-to-one because I'd have a horizontal line that hits in more than one place. But if I restrict the domain to be just x bigger than 0, then it is one-to-one. All right, so assuming that the x can only be positive, then I can write y equals x squared plus 6. So x equals y squared plus 6. Move the 6 over and square root both sides. All right, now, remember we restricted to only this branch. So the x's and the y's are both positive. So I wouldn't want the inverse to be negative, only positive. So my f inverse would be the positive square root of x minus 6. All right, let's look at this guy. Now, remember the cube function kind of looks like a little s almost a little bit. And then I'm shifting left 4. So over here at negative 4, our function goes like that, right? So that is one-to-one because every horizontal line will intersect it only one time. So we write this as y equals x plus 4 cubed. Flip the x's and y's. Cube root both sides. So my inverse function would be the cube root of x minus 4. Now, the x and y's flip. So if I flip this x and y coordinate, it ends up over here. It's symmetric across the line y equals x. So I can get the graph of an inverse function by flipping the graph of the original across the line y equals x. Let's find the graph of this. We're going to flip all of these values. So negative 2, 0 becomes 0, negative 2. There's a point there. Negative 1, 1 would become 1, negative 1. There's a point there. 2, 2, I flip the 2's and it stays 2, 2. 5 square root of 7 would go over to square root of 7, which is a little more than 3, or a little under 3, up to 5, so here. So when I draw it, right, it's going to look something like that. And we can see that symmetry about the line y equals x. We see that here on this next side, right? Here's how we flipped it, and we see that symmetry across the line y equals x. Now notice the x and y's flipping also mean the domain and range flip. The original had domain negative 2 to infinity. That's the range of the inverse. And this one had the range of 0 to infinity. That's the domain of the inverse. All right, so let's find the inverse of this function. So square root of x minus 2 flips my square root function, whoops, right 2 places. I started to draw it to the left 2 places, right 2 places, because it's a minus 2 in there. And that's clearly 1-to-1. It passes the horizontal line test. So we write this as y equals square root of x minus 2, square both sides, y squared equals x minus 2, add 2, y squared plus 2 equals x, flip the x's and y's again, and we write f inverse of x equals x squared plus 2. But now x squared plus 2 would be a parabola that shifted up 2 units, which has 2 branches like that. Look at the symmetry across the line y equals x. Only this branch should be used. So we need to restrict the domain here to be x greater than or equal to 0. This rational function is 1-to-1. Let's find its inverse. So y equals 3x over x plus 5. Flip the x's and y's. X equals 3y over y plus 5. Multiply the y plus 5 to the other side. And distribute the x. And now get all my y's on one side. So I'm going to subtract this term to this side. Factor out the y that's in common. And that leaves 3 minus x divided over. And we get y equals 5x over 3 minus x. F inverse of x is 5x over 3 minus x. Important facts about the inverses. If it's 1-to-1, it'll have an inverse. The domain of the original is the range of the inverse, and the range of the original is the domain of the inverse. That means that the x and y coordinates flip. So the graph, they're reflections about the line y equals x.